Hello, this is Ms. Moore, and today during chemistry we're going to talk about heat flow and enthalpy. Today's essential question: how does heat move through endothermic and exothermic reactions? Okay, we'll start with a quick review of temperature, heat, and kinetic energy. So first off, thermochemistry is the study of energy changes that occur during chemical reactions and phase changes. Kinetic energy is the energy of motion. All atoms are in constant motion, which means they have kinetic energy. And the greater the velocity, or you can think of velocity as speed, the greater the velocity of movement, the greater the kinetic energy. So atoms or molecules with more kinetic energy are going to be moving more. Atoms with less kinetic energy will be moving less. Heat, which is symbolized by a Q, is the sum of the kinetic energy in a sample of atoms. The greater the heat, the greater the kinetic energy. The greater the kinetic energy, the greater the movement. So we could skip the kinetic energy step and say that the greater the heat, the greater the movement. Because heat is energy, it's measured in the unit joules, and that's because joules is an energy unit. Okay. Temperature is a measure of the average kinetic energy of atoms, and the unit used is Celsius or Kelvin. And this is an important one here. Absolute zero, meaning the theoretical lowest possible temperature, absolute zero, is 0 degrees Celsius. Or no, sorry, take that back, 0 degrees K. And that's the temperature at which there is no molecule movement. And this is a theoretical. Absolute zero is theoretical. All right, chemical reactions and heat. How are those related? All right, during a chemical reaction, bonds are broken, atoms are rearranged, and new bonds are formed. That's the definition of a chemical reaction, right? You start with one or more substances, you make one or more new substances, and that happens by rearranging the atoms. Most chemical reactions involve changes in energy, and this is because breaking bonds requires the use of energy, and formation of bonds releases energy. And this energy flow of releasing and using energy is seen as changes in temperature. Okay, that's how we can actually measure changes in energy, by looking at changes in temperature, remembering that this energy is actually heat. Okay, a few terms. We've got something called the system. The system is the thing that we're studying, what we're actually interested in. And the surround is the environment the system is in, and the things that come in contact with the system. So for example, if we were doing a reaction in a reaction dish, the reactants that we put in the dish would be our system, and the reaction dish would be our surround. Okay? In thermochemistry, the direction of heat flow is given from the point of view of the system. So if we're talking about heat flowing out of the system into the surround, or are we talking about heat flowing into the system from the surround? All right, let's discuss exothermic reactions. So an exothermic reaction is a reaction that releases heat. I remember this as exo is heat is exiting, the system, the thing that we're studying. So you want to think of heat as a product, and we have an example here of a combustion reaction of a hydrocarbon that produces carbon dioxide, water, and heat. Now the heat is not going to just sit there in the reaction dish or in the car engine or wherever we're talking about. It's going to float away. So that's why I think of heat as exiting. So during an exothermic reaction, the system, the thing that we're studying, is losing heat to the surround. So we have another example here with the CO and the O2 being our reactants, and the CO2 is our product. And what you'll notice is that the reactants themselves, the atoms of the reactant, or the molecules, have greater energy than the molecules of the products. Now, if we go back to the equation, the reactants taken with all of the products have an equal amount of energy. But because we're forming heat and heat's floating away, if we were just to talk about the atoms or molecules themselves, the reactants have more energy than the products, okay? And the change, this here shows our change in energy, is a negative number because we're losing heat to the surround. In this case, we lost negative 395 kilojoules. So that's an exothermic reaction. Okay, on to endothermic reactions. An endothermic reaction is a reaction that absorbs heat. Endo, I think of that as heat entering the system. Okay, so I remember which one's which. Okay, so heat entering the system. You want to think of heat as a reactant. And here I put the actual heat energy, 113 kilojoules, as opposed to putting heat, either way. All right, so in an endothermic reaction, the system is gaining heat from the surround. Okay, so here, once again, we have our reactants here. And these are our products. Okay. So what you can see is that the reactants, the molecules that make up the reactants, have lower energy than the molecules that make up the products. Again, the actual, that's not going to work. The actual amount of energy on both sides of the equation is the same. But because we're adding heat here, if we just talk about the molecules, this has less energy than those two, okay? So the change here going from reactants to products, the change in energy is a positive number, positive 176 kilojoules. So if you have a positive change in temperature, which we'll talk about in a few minutes, you have an endothermic reaction. If you have a negative change in temperature or in energy, you have an exothermic reaction. And we'll go ahead and end part 1 of the lecture here.